Swayam Prabha. Digital India. Educated India.
Hello, namaste to everyone. So, this is the lecture 2 of the Geographic Information System, where we would understand what do you actually mean by Geographic Information System, how the process of information is flows through relationships to different attributes, how the information is derived, what information can be stored, and who are the users, how it can be used. So, this schedule is to understand what do you mean by science. So, what we learned in the previous class is information system. Now, we will understand what you mean by geographic information science. Science is different from system, how it is different and why it is different. So, that is what we understand in this particular class. Then we would look at what do you mean by a spatial data. People use the term spatial data. What do you mean by spatial data? How it is spatial? When you add certain things, it becomes a spatial data. So, we look at what is a spatial data. Then we look at something called as an attribute data. Spatial data can have huge amounts of information connected to it. So, what are those information are called attribute data. So, how do you add an attribute data? How much attribute data can be there? I will give you some examples of how the attribute data is. Then once you have understood this, then you need to know what is the relationships and how the indexing happens in the geographic information system. For which you have to understand what do you mean by attribute data, what do you mean by spatial data, how the relationships are built, and this is how the geographic information is being applied. So, that is what is meant by geographic information system, using science to system. Then the disciplines that actually contribute to GIS. So, it is not that a specific maybe a computer engineer uses GIS. It is every other engineering background. It may be people from diploma, it may be people from various other backgrounds can use GIS, can develop GIS. So, it is not limited to only specific disciplines. It can be over through every discipline on the earth's surface who is trying to derive meaningful information from data. Then finally, we look at applications of GIS, where GIS can be used. In today's world, there is not a single instance where GIS cannot be used. It can be used everywhere and every applications that you may think on. So, let us look at which are the application areas. I would not go into details of what application, how it is used, but I would just signify which are the different applications that can be used using GIS. Now, someone comes to you and says, I am doing GIS. What does it mean by I am doing GIS? So, does it make sense to say that I am doing GIS? Yes. It means to say that that person is actually developing tools of GIS to solve certain issues. It is not that every tool has been already developed, but certain issues needs tools to be developed over a period of time, or maybe modified to suit certain contexts. It means to say that that person is working on a specific science to develop the tools. The science behind the tool is what he is expert in. So, he is developing those science into the tool, so that anyone who is using the GIS software can maybe use for applications without knowing much about how and why the tool is being built, but you should know the procedures. Now, not knowing much about why and how, what are the mathematical formulations, etc., may not be needed. So, he or she is basically looking at the tools, developing tools to solve a problem. So, when I also say I am doing GIS, it means to say that he or she may be helping to build a tool. So, developing a tool is very different from building a tool. So, now it may be building a tool in terms of adding existing geographic information technologies. It may be that you need 2 or 3 technologies together in order to develop a tool. So that means to say you are building a tool. Okay, so it may be also helping to invent or developing a new ones, which may be out of current research issues that you may have come across. For example, someone finds out that this particular issues has not been addressed over a period of time in research. So with research output you can develop a new tool, then it becomes a contribution. So if it is an open source, so it becomes a contribution to many. So where people can use it over a period of time. Then studying the theory and concepts that are behind GIS and other geographic information technologies is also means that I am doing GIS. So it means say that now anyone who is taking this course is actually doing GIS. You are studying the concept, you are understanding the concepts, you are understanding the technologies behind it, you are understanding the science behind it, and probably you are getting more information about specific aspects of GIS. It also means you are doing GIS. It also means you are studying societal context of geographic information system. If you derive meaningful information that can help society in much larger context, then you are actually also doing GIS. It may be in legal context, it may be in issues of privacy, confidentiality, economics of geographic information. So all of these are using GIS for societal context. So for example, if you are trying to develop maps of a particular region, where degraded region of a forest, and trying to see how the forest was in 1960s, 70s, 80s, 90s, and now how it has changed over a period of time in 2019 or 2020, it means to say that you are trying to understand the benefit that the forest had versus it when it is completely degraded, it doesn't have. So you are trying to look at issues. You can look at the legal context of how the forest, who has degraded for the forest and who is responsible for it. So all of this can be, if you are trying to do, then you are doing GIS. Okay, so when we look at this, whatever we have learned, a hardware, a software is nothing but technologies, systems. But when we say geographic information science, this is the science behind that technology. This is a science that is driving that technology, which means these are the fundamental questions that are raised by use of systems and technologies. So when I say systems, it's a hardware and a software. You use a software to derive meaningful information using an hardware. Now, in order to have that software, you need to have a collection of tools. The tools are governed by science. This science is developed using certain, maybe some research, some usually known problems. So this is where you need to have science. So the science drives technology. So technology is embedded into an software which actually drives the entire process of converting it data into meaningful science or meaningful information. It is basically a multidisciplinary field. It cannot be said that there is someone who is developing a tool is from a particular discipline. Very important concept of geographic information science is information about whether it is being spatial or geographic. When I say geographic, when I mention it as geographic, it has to do something with the earth surface, the process on the earth surface. When I say it is spatial, it has to do with any multidimensional frame. It can be anything, on any you are connecting any object to anything. So that is GIS. If for example, when someone is trying to find out how many pizza stores are there in this particular city, then you are trying to find out that in a spatial region how many pizza stores are there. But if you are trying to find out how do you drive from your house to that particular pizza store, you are actually giving the geographic information about the earth, how you have to move, or either on a walk or on a bicycle or on a car. You are actually defining what is the geographic part of it. So that is the difference between a spatial part and a geographic part. If I am just giving for example, if I say I am Dr. Bharat H. Aital from SIDM, RCG SIDM, so it actually is saying that I am from this department in this institute. It is only giving you the spatial information. But when I say my pin code is 72130 302, it is actually giving you a geographic information. So it is Geographic information is actually a subset of a spatial information which can be used for better information or outputs. Geospatial, you would have heard something called geospatial technologies. It is nothing but a combination of a geographic data and a spatial data. Combining both geographic and spatial data will give you geospatial information or geographic spatial information. So when we are looking at this, how can you apply an information system to a geographic data? Now what did we understand is, we have certain things, certain data which is relating to the earth's surface, so that means it is a geographic data. So how can we apply, how can we derive information from this system? When I say system, it is a group of connected entities, activities which interact for a common purpose. Okay, so when I am actually defining the number of different I am trying to derive different pizza stores in that particular region, I am actually connecting all the activities in that particular region with entities which are nothing but a pizza stores, and using this as an effective system. The information connects for example, if I am trying to drive from my house to that pizza store, I am trying to give certain information which can be processed from a raw data which is just a pizza store, to give a decision making, saying that this is how I have to drive in this particular road, in take a junction and then you reach a pizza store. So that is what is the information that we can derive from the raw data. If you have just pizza stores marked, it means to say that you have just a raw information. So once you connect the information, you derive what is the distance from all of these pizza stores, which is the closest pizza store, and how do you drive from that location to reach the pizza store, then it becomes a meaningful information. So that is nothing but an information system. You have a system, you have an information. When you club it together, it becomes an information system. So when I say GIS again is a geographically referenced, please be very specific here, it is a geographically referenced spatial data. So when I say spatial data, it is information about object, area or a phenomena, as well as a non-spatial data. Now if I have not given any reference to any of those quantities where it is there, okay, so for example, if there is let me give you an example, something like this. Let me explain what do you mean by a spatial data and a non-spatial data. When you look at it here, the maps that you use here is a spatial data, because it is actually referring certain things on maybe geographically connected. You have geotagged images which are actually defining geographically connected data. You have tabular data with lat long, you have postal zip codes, all these are spatial informations which are geographically connected. Now you have certain information, you may have a plan which may not have the coordinates geographical information along it. This becomes a non-spatial data. A photo, just a photo of a building. If you have a photo of Hijli detention center of 1970s and today, it's just a photo. It gives you just information that there's a detention center, but it doesn't give you an information where it is located. So it becomes a non-spatial data. Any films, movies, and the financial statements, books, all these are non-spatial data, but when you have geographic coordinates along with them, becomes a spatial data. So GIS can handle both spatial data and non-spatial data. So it can be combined to derive a meaningful information for any analysis. So when we look at spatial data very specifically, for example, when you look at this particular building, you have an administrative division, you have an address, you have a distance, you have coordinates, you have a place name where this building is located, and you have a postal code. So these are nothing but your spatial data. When you say that Taj Mahal is located in such and such a place, you are defining the administrative location on the earth's surface. It becomes your spatial data. When you are giving a zip code or a postal code, you are actually defining the spatial data. When you are actually giving a coordinates, you are defining a spatial data. So you are defining something geographically on the earth's surface as nothing but a spatial data. please understand that whenever you have certain things that you give a reference to the earth's surface, pinpointing that this is there on this point on the earth's surface, then you are giving a spatial data. Okay, so this spatial data, there can be a spatial data when you look at, for example, when you look at this particular building, the color of a building, the maybe the materials used in that building. So all of these becomes a non-spatial data, okay, which are acting along with the spatial data to give you a meaningful information. So when we look at this spatial data, there is something called as attribute data, which means to say that how the spatial data is actually also has various non-spatial data where you can query and derive information. So for example, what I am showing you on the right hand side is nothing but an attribute data. So these are different can be districts or can be regions in Karnataka, in Bangalore, entire Bangalore district. This is the Bangalore district. You have taluks, Bangalore North, Bangalore South, etc. So you have various places in that region. It has a location code, it has a what is the area of each of these district. Then you have how many residential housing is there, how many households are there. So this residential housings are, then how many households are there, are attribute information that is added to the data. For example, when I was mentioning about the previous building information, so you have a building, you have a postal code, you have a coordinates, you have an administrative boundary, but you also have an associated information of what is the color of a building, what is the material of a building. Those are the attribute data that you actually collect on the ground. Any data to be meaningful should have certain attribute information. For example, if you go to the field, you collect certain data. Even if you have collected geographic coordinates, you should also put in your database or add certain information in the database that can give more meaningful information to those collected data sets. So attribute data is the data. It can be census data, it can be village level data, it can be protected area details. So any of those details which adds value into your main data set is nothing but an attribute data. So this attribute data is also connected by certain relations. For example, when you will go into details of how the relation is built, what are the different relations available, how we connect with the relations, how do we derive, how do we query, etc. in further classes. But when we are looking at this, let us look at as there are certain relations which actually characterize the main data with the attribute data. These are called attribute relations. For example, census district. These are the different districts in this particular map. Now these are different IDs that actually differentiate each of the districts. Okay, this may be district A, B, C, D, but these are the different IDs which actually define this district. So with these IDs, if you go into these IDs, it gives you special information, it also gives you attribute information saying what's the population, how many number of households are there. So this becomes an attribute relationship. These are the attribute relations in that particular data set. So information about a spatial quantity in the meaningful way is nothing but your attribute data. So it gives you more and more information that is necessary. So these data can be stored in a form of a list and a table. So when I say list, always an attribute data is saved as an entire database. If you look at here, I have some of the districts here. So it is these are the different districts. They are district level. These are taluks. These are districts. Then you have geographic area. Then you have number of households. So these are in the form of a table and a list. Always you have geographic information stored as a list or a table in order to derive meaningful information. So using relations, you get into the table, you query data, so you get informations. This is exactly how you may be your for example, if you have looked at Google Earth, Google Maps, etc. So that is how they give you meaningful informations. So having said this, why is GIS important? GIS actually integrates your spatial and non-spatial data. Whatever the data that is available, it can be integrated. Otherwise you should have a lot of physical maps and drill down with informations. With GIS, just with a query of a built-in database, it is possible for you to derive any kind of information. with both spatial and non-spatial information. So you know where the process has happened and what are the different information associated with that process. Okay, so that's where GIS plays a very important role. When you look at GIS as an important tool, it provides a consistent analysis framework. As a tool, it gives you an analysis. You can do all sorts of spatial analysis using a geographically referenced data, which means to say that you know where the spatial data is, which location you are looking at that spatial data, and what analysis you are trying to do. So correlating all this will give you a meaningful information. Then it provides new and insightful ways of manipulating and displaying data. So I did mention that GIS is also a software, which means to say as a software you can derive meaningful and insightful information from it. You can derive new tools, you can derive more data sets. So that is how GIS helps you. It allows viewing and analysis of data. It means to say that already existing data, the derived data, and how and different ways of looking at the data can be looked at with geographical proximity. For example, there is a map that is displayed here. It is actually a proximity map. Now for example, I have these black regions are those which are signifying there is a bus. These are different bus stops in a city. Okay, so when you look at these bus stops, I am trying to see at the proximity of these bus stops how the urban area has grown. So when I derive a proximity map, so and overlay it on the urban area, it is easier for me to say if there is a bus stop, how this urban area in the proximity is actually growing, what kind of growth is happening, and when did it grow, whether it grew with the bus stops, whether it was for different reasons, whether there was industries, whether there was other such regions which actually fueled the growth. So that is why you need a GIS. Now GIS can help you exploring relations. For example, let me take this example here. You have an industry that is located here, you have an industry that is located here. Without this, probably you would have said there are two industries in Kolkata. So and there are certain leukemia cases all around in Kolkata. So get those maps, let us put it on it, then you will look at what are the relationship, if there is a relationship exist or not. But when you look at the geographic information, you have this as a digitized layer. It is a digital layer in your computing system. Then you have leukemia cases as a digital layer. So when you overlay both on this, something like this, you overlay both of them, so you can find out if there is this kind of industry, then there is a lot of leukemia cases around it. So it may be a decision support system which can help you in making effective decisions on where that particular issue is happening and what are the causes of that issue. That is where GIS helps you. It explores relationships between various aspects. So once you have data about the entire city, entire region, you can derive meaningful information just by comparative analysis, something like this. GIS can be an indexing system, which means it can help you index every information. When you look at this, for example, the image on your right hand side, you have a land use data here that I have derived. This is land use data for Delhi. Then you have a transport layer, the transport systems, the connectivity of Delhi. Then I have the city development plan of Delhi. Then I have the water bodies that is there. Then the urban area, the growth that has happened over a period of time. Then I have a slope of the region, I have a vegetation layer of that region, I know what vegetation is there. Then the drainage network and the proposed land use. So for example, when I am trying to understand and model how the urban growth has happened over a period of time, I have used these layers in order to give you a proposed land use model, which means with the rate of urban growth or rate of change in development of a city, it may grow into this vast city maybe in 2025 or 2050. That is what I have proposed it here. Now with this proposal, if you have various layers with geographic coordinates that is connected, it means it sits on each other. You can overlay on all of these, find out what are the issues that are there if the city grows like this and where the issues has to be addressed. where you have to provide basic amenities, what kind of basic amenities, and how it has to be provided. That can be easily located even without any iota of doubt. So for that you need to have precise information about the city. So once you develop the entire data, you can index the data and derive meaningful information from that. So for example, a person who is working in transport may be very interested in looking at the land use and transport layer and maybe an urban layer. So but a person who is working on vegetative factor of city or urban maybe urban ecologist would maybe look at the land use and vegetation part of it, and also look at how the ecology of that particular region is actually changing with the growth of a city. Or if someone is looking at hydrology part of it, they would look at how the drainage systems are there, how the drainage is choked, and because of which how the urban floods are happening and why it is happening, and how it may happen for the proposed land use change over a period of time, maybe in 2025, 2050, or even later. So it can give you directions in order, if you are trying to develop an model city, it can give you directions on how and why certain things has to be adopted in order to make good policy decisions. So when we look at GIS, we have various alternative names. GIS is also called as Geographical Information System. It's also called as a Spatial Information System. It's also called as Environmental Information System. So when I have geographical coordinates along with a spatial information system, it gives you some information about how spatially the geographical information is being put out. So it's called spatial information system. You are giving information about a land, about a geography of a region, hence it becomes a geographical information system. If you are looking at environment aspects of it, as I described in my previous slide, so you are actually giving information about the environment of a region, so it becomes an environmental information system. If you are looking at mapping, if you are looking at facility management, then it becomes a facility management information system. And as I said, it's also a geographical information science which is driving that system. Okay, so but science is developing a tool or a tool in the software, so it may not be very apt in saying that it's a geographical information science. You can do spatial analysis, you can look at desktop mapping. So all of these are alternate names in when we look at GIS as a whole. When we look at GIS, so GIS, when you look at desktop mapping, if you just open up Google Earth and try to map a few places, so you may be limited to whatever the data that is actually available. But when you have a entire GIS system as I said is an integration of remote sensing, integration of computer cartography, computer aided design, and database management system. So with this, as a union, it provides an extensively effective tool when compared to desktop mapping. Desktop mapping can just give you certain information about an area or a phenomena, but it doesn't give you the details that you expect on a larger scale, which can be done using GIS. So it gives you a function that is required to create, manipulate, and integrate spatial databases. Desktop mapping can give you certain information which is already there, but not integrating the spatial databases. So this can be done using GIS. So as I said, GIS is not just one discipline, it has various contributing disciplines. Anyone with any background can become a GIS user, can be an advanced GIS user, and extremely useful for societal applications. So as I said, it may be anyone who is a surveyor, it can be a cartographer, it can be electrical electronics engineer or diploma holder, it may be a computer science engineer, or anyone who is understanding the concepts of geodesy, statistics, mathematics, operation research. Any of these aspects can be used, can be an applicative area when you look at GIS as a technology. So when you look at GIS, application areas are everywhere. So from utilities to marketing to transportation, I have already shown you certain layers how it was built. Okay, so using that layers, the analysis can be done. So it can be applied in transportation, it can be applied in urban issues, it can be applied in health provisions, it can be applied in epidemiology, demography analysis, emergency response, disaster. If a very good case of a disaster is ISRO website. when during the disaster of Uttarakhand floods, if you had seen the NRSC website, they had in a near real time depicted how the floods are moving over that region and how it is affecting the entire region in a much larger context. So that is exactly the applications of both remote sensing and GIS. They use the satellite data and derived meaningful information so that it can be displayed to the audience who may not understand remote sensing and GIS in a larger context. Social science and humanities is a very good application area. People have now started with it. Natural resource management, an extremely effective tool is GIS. Ecology, intelligence mapping, global climate change. Climate change research is a very challenging aspect when GIS is considered. Oceanography, navigation, agriculture, drought management, famine management, all of these aspects, if you happen to visit Bhuvan, you get large data sets of most of these application areas in can be used in certain aspects. So to summarize today's class, geographic information science is both hardware and software to solve a problem. When I say science, it is a tool, it is a science to develop the tool as a software. Now the spatial data is a data with geographic information that can locate object or phenomena on the ground. Attribute data is added information to existing information as maybe a spatial data. Then relationships and indexing defines how attribute data interacts with the spatial data. So we will learn more about what is relationships, what do you mean by indexing. There are huge number of disciplines. Everyone who is doing this course can, or every engineer, every diploma holder, or anyone who understands the basics of it can be an effective GIS user. Then applications of GIS can be in every field that you name. So this is about this class, but in the next class let's look at how GIS originated. Who was the first one to define GIS, how it originated, what are the different definitions of GIS, and who are the different GIS providers who are available in today's world. So different GIS software developers, software providers, etc. We'll look at it in the next class. Thank you very much.